Hello, everyone. We are having all the technical chaos today.
Yeah. And unfortunately, I've got to go
When?
I've got to go at 4:01 for sure.
So we only have 20 minutes?
No.
Oh, we have an hour and 20 minutes.
Yeah, hour and 20 minutes. Yeah.
Okay, sorry. Time zone flail. All right, so...
Yeah, so something about Zoom is being blocked by the Mac, and it's just Zoom. And I can't load it up in the browser, and I can't load it up in the actual Zoom app.
And my Mac is like, I'm good.
Yeah, yeah.
All right.
Weird.
I have fixed my shirt attempting to green screen. It's a blue shirt. I have no idea why it's trying to green screen. Okay, I am apparently touching my desk with my legs, and heavy gestures made everything move. So, all right, I'm no longer touching the desk.
You're making like a bonk noise.
My camera tripod is giving everyone a bit of motion sickness right now. All right.
So apparently I sound like I'm echoing. That old problem. You think of why I might be echoing?
Mm-hmm. Hold on.
Okay. Echo.
It may not be the correct mic.
Oh, huh. That's not surprising. Yep. Oh my God. Okay, hold on.
Okay, I'm going to switch it so I can hear you directly for a moment, but only a moment because I like myself.
I take back all of the insults that I hurled at my Microsoft computer because I did a reboot and my Mac decided to not use my proper microphone.
See, I don't have these problems usually. So I think you have simply hurled too many insults at too many computers.
Right. So now I'm like on a list.
All right. So we're getting better.
Okay.
All right. So the problem was not an echo. The problem was the wrong mic.
Yes. So the echoes are gone. Okay.
All right.
But then, like, where was this other microphone? Is it on the Mac Mini? Is it on my... Weird. Yeah, that's not right. Okay. Right. So, hey, everybody. How's it going?
Chaos. It is chaos.
Yeah, totally chaos. Man, what's happening? Oh, so you know how I love Death and Robots? I don't know if I've mentioned this many times in the past, but it is this amazing series on Netflix where it's like a bunch of short animated stories where they took science fiction short stories and then made animated versions of them. And so they're in many cases they're very short, like, you know, they're 5 minutes long or they're 15 minutes long. Occasionally they're up to 30 minutes long, but they are so good. I mean, like, for anybody who has not watched them, I envy you because now you get to watch them. And for me, I watch them every couple of years over and over and over again because they're so good. They're so good. Like I think if I had to pick my favorite thing, it's Love, Death, and Robots.
Really?
Like I would pick that over Ted Lasso, over The Expanse, right? Like it is my favorite. Yeah. Like if you haven't watched them, oh my God, they're so good. And they are like, you know, I don't know who the exact short story authors are, but think of like Kim Stanley Robinson or David Brin, or, you know, like they are
top names.
Yeah, classic science fiction stories, and they've got 3 seasons of them. So, like that's my highest recommendation. But now the team behind it, and I don't know whether this is like a permanent move, like it's now been canceled on Netflix, and now it's on Prime. But it's called Secret Level. And what they've done is made short animations on video games. So, and like role-playing games. So there's one on Dungeons and Dragons, one on Pac-Man, one on Armored Core, And there's like some pretty big names that are in these animations, and they're wonderful. And they're, it's the same spark of creativity. Like imagine if you were tasked with making an animation based on Pac-Man, right? A 30-minute story about Pac-Man. Imagine what, and yet, and Warhammer 40K, and the Warhammer 40K one is probably the best. It's so good.
Cool.
Yeah. So we just gobbled them up last night. Just watched them all, just one after the other. I wouldn't put them exactly as highly as Love, Death, and Robots, but they're right up there, and like surprisingly good considering what they had to work with. Arnold Schwarzenegger does the voice for.
What is the name of this again? Because I'm currently only remembering Love, Death, and Robots.
It's called Secret Level. It's on Prime. Yeah, it's brand new. Just came out 2 days ago. And just chef's kiss. So.
All right.
Yeah, I loved it. And they're short, and yet the take on the video game is stronger or looser depending on it. Like if you watch the Pac-Man one and you're like, wow, that's a chilling, dark science fiction story. Bleak. And I'm like, yeah, that was based on Pac-Man. And you're like, no. So in some cases the connection is a lot more
tenuous.
Tenuous, yeah, exactly. Than it is for the ones that are very strong. But still, yeah, it was phenomenal. Anyway, I'm ranting here. I'm raving. But like I recommend stuff to my kids.
Yeah.
And I have this limit where, like, if it's not phenomenal, I won't mention it. And then they know that if dad is recommending a show to watch, then it's going to be good, as opposed to, I watched this thing, it was kind of fine, you might like it, I don't know. Right? No. It's only the best. So, and I have finished the second act of Path of Exile 2. So now I'm on to the third act. Yeah. It's good. It's really good.
I've been consuming nothing because I've been madly working on creating things. And it turns out you have a choice with your brain. You may either be
100%.
consuming creative content or creating content. You cannot do both.
No, that's true. You can't do both at the same time. But yeah, and this last week has been consuming.
Yes.
So,
yeah.
But I have some creation that I have to get to, so I have to dial back the consuming and move back to the creation. We're going to do our year in review, which is going to be fun, and we're basing it on all the stuff the highest voted stuff on our YouTube channel. So,
that's cool.
People. Yeah, every week we do a vote on the channel where people tell us what they thought was the best space news story, and so we're now going to sum up those stories, which were the ones everybody liked. So
I feel like I would like to also try and data mine that, because it's publicly available data, and there could be a cool paper out of that.
Oh yeah, maybe. What kinds of stories are in? Yeah, it's funny because a lot of the times it's obvious, but many times it's not obvious. Yeah. People were more excited, and I forget what it was. I think of the launch of Europa Clipper over the sixth flight of Starship.
Yeah, I agree with that.
Yeah, me too. And it was great to see that the audience felt the same way, which was like sure, yeah, sixth flight of Starship, that's great, but Europa Clipper, come on. How amazing is that? So.
Europa Clipper is going to potentially set us up to send another mission that will find life.
Yeah, exactly. Oh, I didn't realize you have a dog.
Yeah. She came over and she was pawing my desk, making everything shake. So I was like, I will pick her up until we're ready to record, because that will prevent her from shaking the desk.
Is the her collar getting green screened?
Yes, it is.
I can see the green.
Green. She has so this is my no take just throw dog. And so one of my friends got her a collar that has the seagulls from, I forget which Disney movie it is, that are like, mine.
Mm-hmm.
So she has a collar that's
Finding Nemo, yeah.
Yeah, she has the Finding Nemo seagulls on her collar with the word mine. And it has a bright green fuzzy inside.
Aww.
She has not forgiven me for going to AGU for 4 days.
How was AGU?
It was really good. I have to say, I actually like the DC conference center a lot better than the San Francisco one.
Yeah.
Because when you had 30,000 people in San Francisco and you were all trying to use the crosswalks, you could tell you were at a 30,000 person conference.
Yeah.
But the convention center in Washington, D.C. is one big continuous building. And so it was a big enough facility that you never felt like you were being overwhelmed the same way you might feel at Dragon Con or
Right.
where we were in San Francisco. And so that was a relief.
That's good. I signed up as a journalist,
Yeah.
like for the AGU, and so now I'm going to slowly digest all of these stories there and mine it for stories. But so probably over the next month or so, we will be covering stuff that wasn't widely reported from the AGU. I didn't see a lot of press releases coming out that were really covered, and yet there's a lot of interesting stuff that happened. So it's back to shoe leather journalism as opposed to.
I ran into our old friend Kimberly Cartier.
Mhm.
Like, it didn't. I don't know how she works for AGU.
She works for. She's the writer for EOS.
Yeah, and so she runs EOS pretty much. And so I was going up one escalator while she was coming down the other, and we had a moment of, it's you. Hi, I love you too, dog. The dog will be evicted for recording the main part of the episode, but the dog has not forgiven me.
Right.
Yeah, so that was super cool. We got to get a glass of wine together, hang out, catch up, talk about all the weird stories coming out right now. And one of the big questions that a lot of organizations are having to deal with right now in the US is, what do we do if nonprofits have to worry about losing their nonprofit status by talking about climate change? So, yeah.
Yeah, what do you do? Talk about climate change.
Right. And that seems to be the ongoing decision of, we're not going to stop. Everyone I talked to said, we will keep going even if we're told we'll be silenced.
Yeah, I think that's the way. All right, let's get started.
Okay, you have to get down now. No, seriously, please get down. I'm not touching her. Off.
Yeah.
Off.
Good luck with that.
Off. No, that's the opposite of off. Okay. This is where wow. Okay. There we go. Down. Okay. I have a very needy dog.
Yeah.
All right. Hello, GeoJim. Hello, Keeper of Maps. Hello, Not the Brain. I lost my mouse. Hello, Mouse. Hello, Null Denominator. Hello, Sully Two Cats. Hello, Guido. What's for dinner? Hello, Alan Gross. That's everyone over on Twitch. Do you want to say hi to the folks over on YouTube while I set up my audio recording?
Well, the problem is that YouTube only tells you if they've said something within the last 5 minutes. So there's just Dave Moore.
Okay. So
but I can see Paul Disney, Wacky G, Levi Rivers, Zapfan, Ellen Gross, and also Guido Bibra. Twice.
Michael
Dave Marvin,
Hensby.
Tia Krall, Ellen Gross, Michael Hensby, Robert Great. So let's go.
Okay.
Keyboard battery's very low.
Are you plugged in?
No, I don't. This one is just Bluetooth. But it's gobbled up 3 batteries in a week, and not like I've been using it a lot. So I need a different keyboard.
I strongly. Oh wait, no, you. That's the keyboard, not the mouse. You're having issues with.
Well, I mean, I hate the Mighty Mouse so much.
Yeah, get something different.
I have something, so we should get started. But my mechanical keyboard doesn't awaken the Mac very well, and so a lot of times it won't start back up again. So I had to go with the Mac approved Bluetooth keyboard, but now I need to swap out its batteries every 5 minutes.
I have a wired keyboard. I love my wired keyboard.
Yeah, I'm gonna have to get just like a wired Mac keyboard.
Yeah, I can help as needed. Okay, I am pressing record on the audio. I am pressing record on the video. We are recording.
Okay. Here we go. Astronomy Cast, episode 737. the weird science stories in 2024. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I just got back from the American Geophysical Union meeting in Washington, D.C. It was great to get to see so many people that I haven't seen since before the pandemic. And you and I are both going to be processing all the amazing science that came out of that meeting for quite some time.
Yeah. They don't do a great job of like the press releases in the way that the American Astronomical Society meeting works. And so I have to go through it talk by talk, speaker by speaker, poster by poster, and go and say, like, is this interesting? Is this interesting? And then I pull out usually 30 or 40 stories out of the AGU and then digest them down. And often that turns into about a month's worth of reporting at Universe Today for all of those stories. So we will be trickling out what I think are the interesting stories out of this meeting, and hopefully it'll be stuff you've never heard. So, you know, one of the things that I'm really proud of now with Universe Today is just how much reporting we do of stuff that nobody else is covering these stories. You know, I'm digging deep into journals and archive and getting tips from readers and scientists, and so I think our reporting is quite unique now compared to other people. Yeah.
I do have to say one thing AGU does do so much better than any other professional society is their award ceremony was black tie recipients and presenters. So the pair of presenters, she was in an amazing, immaculate gown that was like, I someday want to be a little old lady in a glittery gown that looks that good. The men were in tuxedos most of the time. And so you have these scientists who are probably for the first time in their adult life, other than weddings, wearing gowns, and they all had flowers, and they were using teleprompters. So everything was like produced. And it was like an award ceremony I was pleased to be at. And they had this amazing video production of why the people got the awards. It was everything you would want in a society award ceremony. Yes.
It is a thing. It is a thing I've never said.
It's true. I've never said it either.
2024 was a strange year. I'll let your imagination take flight and consider how 2024 was weird for you. But for space and astronomy, we had some interesting, revolutionary, unsettling, and downright weird stories pop up. Today, let's talk about them, and we will do it in a second. But first, it's time for a break. And we're back. All right, I'm going to come right out here. I'm going to take the first story because I think I really need to sort of set people's expectations here. And that is that we have all been living a lie. And that is that Uranus and Neptune are different colors.
Yeah.
Uranus is this sort of light blue color, and Neptune is this deep blue color. You can tell them apart at a glance. If this is what you believe, you are wrong. That these two planets look very familiar. You could, put them in front of you and switch them back and forth, and you would have trouble telling which one is which. And the reason is because way back in the beginning, when the Voyager spacecraft did its flybys of both Uranus and Neptune, when they did the Uranus flight, they were very careful to calibrate the colors and make those colors available, and people have been thinking about them for a long time. And when they did Neptune, the image was done very quickly, and they did a very kind of quick stab at getting the color, and they produced some images, and the images were provided to the press, and the color just stuck. And in this case, the color was, like blue, but not the same sort of greenish light blue that Uranus is. And nobody kind of went back and revised it, even though planetary scientists knew that was, not the true color of what you would actually see if you were floating above Neptune with your own eyes. And then some hero did a follow-on study, sat down, looked at the raw data, produced an image of what Neptune would actually look like with your own eyes, and lo and behold, it looks very similar to Uranus. And so I don't know what to tell you now, right? But this is the universe that you now find yourself in.
It is truly delightful, and it is an explanation of why we really need the little moral equivalent of film camera color correctors on Mars rovers, and we need to process the images first quick and dirty, and then slow and carefully. And the slow and careful needs to come weeks later, not decades later.
Yeah. What have you got?
So the weirdest story to me, the one I will be giggling over in terms of this is the strangest thing that could happen, is the story of Ziva. It all started with a Radiolab episode where Latif Nasser was talking about a poster on the wall of his child's bedroom that had next to Venus a small object that he read as Zoozve, Zuva. And he's like, I didn't know Venus had a moon. And he went,
Called Zuva?
Yeah, exactly.
Yep.
So he went down the internet rabbit hole and found nothing. But because of who he is and the connections he's made over his life, he then proceeded to reach out to Liz Landau at NASA, who's like, no, there isn't an object called Zuva.
Why is it on this poster? Yeah.
Right. And so then she got to looking at it and thinking, and as other people get called into the conversation, it was realized this is actually the object 2002 VE. Not ZOOZ 2002, 2002 VE, and it was a quasi-moon of Venus. It's still there. It's still doing its thing.
Right.
And a quasi-moon is an object that is in a slightly more or less elliptical orbit than the world it's associated with, so that they're both going around the sun with the same length year, but the one object is either inside the orbit or outside the orbit of the main body, depending on where it is in the orbit. And it appears, if you graph it over enough time, to be going round and round in almost like a butterfly flapping its wings pattern.
Yep.
And so
is it a horseshoe librator, or is it a quasi-moon?
It's a quasi-moon.
Okay. Yeah. I mean, there's a whole bunch of these kinds of objects, and I think people were quite familiar with the one that came close by the Earth. I think from September to December, we had a quasi-moon, and it's the same situation where the object gets close to falls into the gravitational well of the larger object for a little bit, does a couple of orbits around the planet, and then sort of walks back away out into solar orbit. And this happens apparently every couple of years for Earth, and it must happen every couple of years for Venus as well.
And some of them stick around a whole lot longer. Some of them are very passing because it turns out their period of going around the sun is just enough different that they're only here for a little bit of time. Now, the thing was, this entire story ended up leading to the International Astronomical Union deciding to permanently name the quasi-moon Zuva.
It's awesome.
And that breaks every rule on how things normally get named, but it's just this wonderful moment in time. And then Latif and the other folks involved in all of this were like, can we name something else? And so there's right now a naming contest. All of you can vote on to name one of Earth's quasi-moons. They did a public suggest names. I was actually one of the people on the committee to help downsize the names that were selected to a list of 10. And so you can now, because of a really badly labeled quasi-moon on a children's poster, go actually name one of Earth's quasi-moons.
That's amazing.
It's so weird. It's just weird.
All right, we're going to continue on with the strange stories, but first it's time for another break. And we're back. All right, so I want to talk about this strange discovery that was made this year, dark oxygen.
Yeah.
And this was an analysis of these strange objects that are found down at the bottom of the ocean. And these, I forget what their name is, but anyway, they're these little blobs of metal that sit down on the bottom of the ocean. And companies are quite excited about being able to mine these things, that you could run a net along the bottom of the ocean and you would just bring up tons and tons of these. And they're very concentrated in the kinds of things that we need in our modern economy, cobalt and various other fairly rare metals. And so it's thought that, in fact, these could be a huge source for what we need for electric cars. But also, harvesting them would cause tremendous damage to the undersea environment. And so, people have held off mining these with concern of the environmental impact.
Yeah, they're called nodules. We are not creative at naming things. They're just nodules.
Yeah. And so scientists have been looking at the sort of chemistry that happens with these nodules and found that they are a producer of oxygen in a part of the ocean that is normally starved for oxygen. Like up at the very high, at the top of the oxygen, you have where the ocean sort of interacts with the atmosphere, and you get this mixing of oxygen into the water, and that can sort of percolate down and provides this source of oxygen for life. But once you run out of that oxygen, then things get very starved for life, and you need another, or things get very starved for oxygen, and so you need a way to replenish that. And they've pointed to, in fact, these nodules at the bottom of the ocean could be trickling in oxygen into the deep ocean, and then that could be a source of oxygen for life. And obviously this has implications for entire ecosystems at the bottom of the ocean, that, it's not just dredging through that you're going to cause damage, but in fact, you might be taking away their source of oxygen that they need.
Yeah.
But the other thing that's really interesting is that this could be a source of oxygen for other planets, for exoplanets, where they're covered with ice and water, and that no sunlight is making it down, and there's no way to mix in oxygen into the water, but you could have this replenishment of oxygen into the ocean from these nodules that sit at the bottom of the ocean. And I thought that was really interesting and weird. And a lot of people really got grumpy about the name, about dark, because it's a dark matter, it's dark energy, dark Big Bang.
We're not allowed to name things anymore.
Yeah. But so oxygen producing nodules at the bottom of the ocean, and
it's naturally occurring electrolysis, basically.
Yeah.
It's manganese
batteries
and cobalt that, when put in salt water, produce oxygen.
Yeah. Batteries at the bottom of the ocean.
Yeah.
There are batteries, natural batteries at the bottom of the ocean. That is weird. What have you got?
So it turns out that some of the active galactic nuclei out there, so these are massive black holes that have material falling into them, and they have jets, and the jets are flying out through the gravity, not through the gravity, through the galaxy. And the beams can trigger Novae events in stars that are located too close to the beam. So there are literally actively feeding black holes spewing out jets that, when they basically have a glancing blow on stars, will trigger outbursts. These are actual novaes that are occurring, and it's in part because the material is just filling up the star and it's going boom. I love it. I just love it.
Yeah. I mean, like this idea of the classical novae is where you have this white dwarf star that's feeding off of material from a companion star. It builds up enough material on its surface, and then it has a little explosion, a little tantrum, and then it goes back to square one and starts building up the material on its surface, and then has a little tantrum, and so these jets that are crossing tens of thousands of light years are, and like the exact mechanism is still not known. Like, is it that it's actually just striking the stars with these white dwarfs with material, and that's building up to the point that they're having novae, or Is it just that as the beam is passing through, it's causing turbulence that's sending ripples of material that was already there, gas clouds down? Is it somehow puffing out the outer layers of the companion star so that it's, a more easy to feed as it's increasing the temperature in the area? Like, the actual mechanism is still not known, and yet, it is so weird.
And this is one of those findings that was discovered thanks to statistics, which I honestly would love to sit down and talk to the person who figured this out. And I was like, what made you realize that this was happening? Because it was literally you see the jets in radio, not optical. And they noticed that novae occurred more frequently near, not inside, near the radio jets. And it was simply a statistical, there's more here than here. But those aren't places where normally you go comparing stuff. And so I'd love to know what caused them to look at the placement within galaxies of these novae. It's a super cool result. And this is why we need to have telescopes in space, because they can see such higher resolutions. This is a Hubble discovery. And that allows us to figure out where these things are located. It's just really cool. And weird. It's weird.
Yeah. All right. We're going to talk about some more weird things, but it's time for another break. And we're back. All right. So this is one that I've been following, which is an explanation for Betelgeuse. And, we saw Betelgeuse dim down a couple of years ago, and now people think that it's probably due to either some giant cell on the surface of Betelgeuse, or maybe it's some gas cloud that had been produced that now the star was passing in, behind, or the cloud was passing in front of Betelgeuse, and that's weird. And Betelgeuse is a variable star, and we know that it has these regular pulsations that go off of its surface, but it actually has two cycles. There's the main one, and then there's a secondary cycle that is more like about 1,300 days long. And astronomers always wondered, what is causing this second cycle? The main cycle, sure, the star is kind of pulsating in a way that all supergiants do, but why this second variability? And researchers have proposed that, in fact, it's due to a binary star that is orbiting around Betelgeuse, that you've got this star that is orbiting roughly the distance of Jupiter. It's very close. It's probably like a sun-sized star that is orbiting around Betelgeuse. And so the variability that we're seeing is just depending on the position of this star, that when the star goes behind Betelgeuse, from our perspective, then it disappears, and the total brightness that's coming from Betelgeuse goes down, which is different from when it's on one side of the star or the other, or when it's passing directly in front of it. And so we're getting this variability caused by the star. And I just love this idea that there is a companion star to Betelgeuse that we just can't see through any other way but just measuring subtle changes in brightness, kind of in the same way that we detect exoplanets based on the changes in brightness as this as the star in this case is passing in front of Betelgeuse. And I mean, this is, these things, these binaries, where you have binary stars that are passing in front of each other, transient, what's the technical term? You're the astronomer here. Transient,
transiting planets.
But like stars. Stars.
So
transiting,
eclipsing binaries.
Eclipsing binaries, that's it. Yeah. And then in many cases, you can't tell that they're two stars orbiting around each other. You can't split the difference, but you can tell because the way
lines.
You get the variability in the brightness of the star. Yeah. And sometimes one star is in front of the other, and so it has one spectral characteristic, and then the other time, the other one's in front, it gets a totally different spectral characteristic. And so it could very well be that Betelgeuse has a binary companion that we just haven't been able to find.
So for the next story, I think we have time to hit two rapid fire ones. So one rapid fire one that's on my list is Jupiter's red spot is not the same red spot observed by Galileo, we now think, because there was a period of observations where a whole bunch of really prominent people were looking at Jupiter and never saw the red spot. Yeah. And so there was this evolution in position and size, and then nothing.
Yeah, from like the 1600s to the 1800s.
Yeah. And then about 190 years ago, it came back. And so the question is when's it going to disappear on us again? And we're seeing that same evolution and position that was seen in the past. And I love that Jupiter just grows giant red spots.
Right. But also that our total understanding, and this is back to your whole life as a lie, right? that Cassini first saw the red spot back in the 1600s, and then people saw the red spot later on, and it was assumed that the red spot has been there for a long time, maybe thousands of years. Maybe it's a permanent fixture on the surface of Jupiter. But someone said, well, did anybody observe it after Cassini, but before the 1800s when they were making regular observations? And astronomers were like, no, nobody saw it. Like people were looking at Jupiter, but nobody saw the red spot.
Right.
And now people are quite sure that it just wasn't there.
And that is amazing.
Yeah. That it's a totally different spot than what Cassini saw. And what astronomers see today are different spots.
And we're learning more and more about things that happen on century scales, which means pre-modern technology and recording. So we don't have modern examples of them, but the sun, we both flagged the story. The sun, it turns out, has superflares that are so violent, they would brick your phone. So no aurora pictures for you, and no modern technology for any of us.
Yeah. I mean, we see we know of the Carrington event, which was this really powerful solar storm that happened back in the 1800s. And it was, people at the mid-latitude saw auroras. People watched telegraph lines catch on fire. And this was before the modern technological world that we live in. And this was, the most powerful flare that hit the Earth in modern memory. But astronomers have seen other really powerful flares going off of the sun, just in different directions, stuff that would have matched or exceeded the Carrington event. And there are these tree rings that show evidence that there have been far more devastating solar flares hit the Earth over the last, say, 5,000 years. And the scary part is that the Carrington event isn't one of them. It didn't register. It wasn't powerful enough to be one of these flares.
What got me about how they did this was it also has impacts on, that was not an intended pun, on like how we do paleontology and archaeology, because when these massive flares hit our upper atmosphere, they cause the creation of significantly more carbon-14, which is the kind of unstable carbon-14 that then becomes part of carbon dioxide in the atmosphere, gets ingested vape. I don't know the correct respiration into plants. It becomes part of plants. And so they're looking at the tree rings, and some of the tree rings are like, I shall have a whole lot more carbon-14 because the sun was angry. And so you can imagine someone had a fire with a bunch of branches that were very young from a year of an angry sun, and they're going to totally carbon date that as being much newer than it actually was. And that is just weird.
And what I love is a new paper came out, I think yesterday, which was
flares once per century.
Yeah. So astronomers are trying to figure out, okay, so we know that the sun can produce these kinds of flares. How often does this thing happen? And so they used Kepler, and they looked at historical information taken by the Kepler spacecraft of 55,000 stars. And because Kepler looks at this giant field of stars at the same time, they were able to put together a total of 220,000 years of data from Kepler staring at all of these stars. And then back to statistics, they were able to calculate how many times they saw flares in that population, in those hundreds of thousands of years of star life. And they were able to calculate that on average, a star like the sun produces a very powerful Carrington event level solar flare every 100 years or so. Now, not in our direction, but just in random directions.
Yeah.
And so we are, when you think about all of the possible directions that the sun can blast its flares, the ones that come towards Earth are a fraction of it. And so, but like worse than the Carrington event, like the ones that would be recorded in the tree rings, that's what the sun can do every 100 years.
And just to bring up something I don't think we have time to get into, and I don't know a lot of details on, There is the realization that one of the earlier mass extinctions was caused by a more massive asteroid striking the Earth than the one that killed the dinosaurs. So about
Right.
4.5 billion years ago, there was a asteroid that they named S2 because, again, we shouldn't be allowed to name things, that was 50 to 200 times larger than the Yucatan Peninsula
Oh,
impact. It vaporized 10,000 cubic kilometers of rock that then recondensed into molten droplets.
wow. That's
Yeah.
amazing.
So it completely wrecked our early planet, but because of the way it mixed things up and the way it changed our atmosphere, it allowed a massive boost of life formation afterwards.
Yes. Yeah, yeah. It's funny that when you have these devastating impacts, then life has encouragement to evolve. I guess,
Yeah.
various ecosystems are blasted to smithereens, and then that gives other life forms a chance to evolve. And the other thing, back to the Carrington event, and of course there are supernovae that have happened in the last few million years,
Yeah.
that it might be that an increase in ultraviolet radiation that's able to reach the ground also encourages a lot of mutation in life. Now, mostly it just leads to horrible cancer, but every now and then it leads to life finding a new way to dominate in its niche. All right. We're sort of right at the end of the show, but I think there's one story that is perhaps the weirdest that we have been watching for years, and I think we just got some interesting insights into it just at the end of this year, and I think a lot of our reporting next year is going to cover this, with Euclid coming online and Vera Rubin coming online, and the dark energy spectroscopic instrument. And this is from DESI. Is, we talk about the Hubble tension, how the expansion rate of the universe is different at different times when we measure it, and for the longest time that was assumed to be measurement error. This is the Hubble tension, the crisis in cosmology. And now DESI has done this incredibly in-depth look at the shape and structure of the universe and the various parts of the universe over billions of years, and said, nope, it does look like things were variable throughout the history of the universe, that maybe the expansion rate of the universe has been changing over time, that maybe the influence of various forces in the universe were different at different points in time.
The thing that I think everyone can agree on right now is, if dark energy comes into existence and plateaus before z equals 2 within the past several billion years, plateaus within the past several billion years, you can erase the Hubble tension. Now, the problem is no one quite knows what to blame on dark energy. And so I went down a magnificent rabbit hole of black holes cause dark energy. And it's like mind. There's a lot of people and it makes a lot of sense, but it doesn't fully work the way I thought it did when I read the papers initially.
Yeah.
And a comment I saw was, astronomers are going to blame anything that comes into existence within the first billion years or so, after the first billion years or so, as a possible cause. And we don't know yet what the actual cause will turn out to be.
Yeah, and so, maximum weirdness, either like just the standard model of cosmology as we have come to understand it, as additional modifiers that nobody had ever figured out, or that things that we thought were held stable throughout the history of the universe are actually changing. The amount of dark energy, the pull of gravity, the amount of dark matter, like these things, somewhere there is new physics.
Mm-hmm.
And now it's up to the astronomy community to find those physics, and they're excited.
Yeah.
I mean, it's like, what a present for physics to have this mystery, but also have enough clues and hints pointing in various directions that people could start to track down what exactly is going on. And so I think it's going to be weird, and it's going to be fun, and I think we're going to have a field day in the next couple of years of just reporting on all of this stuff.
And what I'm loving is, it looks like they're going to be able to improve our understanding of the insides of black holes by realizing we have to fix some of the wild assumptions that we've made of just being able to ignore stuff, because that stuff we've been ignoring is cosmologically relevant.
Yeah.
So
Yeah,
yeah, it's
fun.
super cool.
All right. So I hope you guys enjoyed some of the interesting, weird, strange stories that we've been watching this year. Thanks, Pamela.
Thank you, Fraser. And thank you so much to everyone out there who is a supporter of this show through Patreon. As always, you can also support Fraser and I through Universe Today on Patreon, through CosmoQuest X on Patreon. To those of you supporting this show, thank you.
And you can give it as a gift.
Yes.
If you're like
that's
in
a
the
thing
car
now.
right now,
Yeah.
and you are the supportive spouse of an Astronomy Cast fan, and you're like, what can I give this person who has everything, who wants for nothing, who just wants knowledge and curiosity? You can have them join our Patreon. If you go to patreon.com/astronomycast/gift, you can give the gift of knowledge.
Yeah.
And you can also do Universe Today/gift. You can do CosmoQuest X/gift. You can give astronomy, give our Patreon as a gift. And then you get all of the benefits of being a full-fledged Patreon member with none of the expense. So consider giving that as the gift. You're welcome. I just saved you having to actually go to the mall and shop with the zombie masses.
Yeah, this is also a great gift for the elder members of your astronomy club who listen but may not have the resources because they're in America to be able to afford Patreon. There's so many people out there who could be in your life who just can't be on Patreon, and you can change that. Anyways, I am going to thank this week Alex Cohen, Andrew Stevenson, Astrosets, Benjamin Davies, BogieNet, Bruce Amazine, Claudia Mastriani, Daniel Loosely, David Gates, Dr. Woe, Elliot Walker, Felix Goot, Galactic President, Scooperstar McScoopsalot, Glenn McDavid, Greg Wild, J. Alex Anderson, Jean-Baptiste Lematney, Jeff Wilson, Jimmy Drake, John Veit, Just Me and the Cat, Keith Murray, Klambadrav, Love Science, Laura Kedison, Marco Iarasi, Matt Rucker, MHW 1961 Super Symmetrical, Michael Regan, Nate Detweiler, Paul L. Hayden, Planetar, Ron Thorson, Scone, Semyon Torfason, Stephen Coffey, Thomas Gazeta, Tushar Nakini, and those are the humans whose names I have pronounced in variously correct levels, and you can add names to our list at will.
Thanks, everyone, and we'll see you next time.
Bye-bye, everyone. I deeply appreciate and am grateful for everyone who joins our Patreon. I love the wild names some of you put in. So yes, you are triggering multiple forms of emotion, and it's appreciated.
Confusion and delight.
Yes.
Delight fusion.
Well, and one of the other problems I run into is people who have umlauts and diacriticals and stuff on their names. When I export it, those become like square roots and degree signs, and I have to be like, oh shoot, I remember typing this on the website.
Right. What is that word?
Yeah. So like Thomas is spelled with a square root and a degree symbol for the second O. So what Mac did you get?
I got the Mac Mini. I just got the base Mac Mini.
And it's working for streaming and recording?
Oh God, it's so fast.
Okay.
Yeah.
I'm trying to figure out if I replaced my computer before tariffs hit. I was holding out for the new M4 Studio in the spring, but if there's a 25% tariff, I won't be able to afford that.
Yeah. So the problem with the Mac Mini is that the base model is ludicrously priced. Like you as an educator, you could get one for $499.
Yeah.
And it is fast.
Yeah.
It is really fast. And the base model comes with 16 gigs of RAM, but it comes with only a 256 gig hard drive. But now you could stick in has Thunderbolt 4. You could attach a really fast external drive. You can get around that. but if as soon as you want to start upgrading, like you want to go to the pro version, you want to add, maybe go to 32 gigs of RAM, you want to add, you want to add a faster, like a bigger drive on it, the prices add up pretty quickly. And, you could fully max out this thing for probably close to $5,000.
No, that's true.
But I think just as my guess is just the base model will outperform your Mac Pro.
Yeah. Well, it's an i9 2019.
Yeah.
So it is still super competent.
Yep.
But I'm starting to hit software errors where the software is like, you don't have a silicon chip, so we won't do that.
Yep. Oh, Alan Gross is saying you didn't mention that you saved the stream, and then they saved.
It's true. It's true.
Saved and uploaded.
So Third Rock Astronomy over on Twitch asks, how can we say the Carrington event didn't even register when we had no way of accurately measuring the flares from the 1859 event? So it all comes down to the tree rings.
Yeah, the tree rings.
Yeah.
So the Carrington event isn't in the tree rings.
And we have trees from 1859, including in my yard. So we simply are, this is ludicrous to me. They are doing C14 measurements tree ring by tree ring.
Yep.
It's wild and amazing.
So the way they do this is that they have samples of trees that have been preserved in different ways.
Yeah.
And so you have like really old trees, like the bristlecone pines that are 5,000 years old, that they have in places in California.
Yeah.
But then they have timbers that were used to build old buildings, and they maintain samples of these timbers. They have trees that fell down into lakes and went down into the bottom to this low oxygen environment that you can go down and you can pull these trees up, and they will be thousands, tens of thousands of years old. And so they have these overlapping samples of trees from hundreds of thousands of years ago until now. And so that when they want to figure out now when a tree lived, they can look at the tree rings of that tree, and then they can match it against this historical fingerprint
because
of
the
all
width
of the trees
due to the seasonal variations.
Thick, thin, thick, thin, thick, 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 thin, thin, thick, right? And you're like, where does that match up to all of the tree rings that we have? And then they can cross correlate those with the ice core samples.
Yeah.
And so they can go back and look through those tree rings one at a time, as you said, and go measure the carbon-14, measure the carbon-14. Whoa, spike right there.
Yeah. And what's also getting me is the permafrost is no longer permanent. And as it melts, weird shit is coming out of the permafrost. Yes. There was recently an entire horse from 40,000 years ago that as it thawed, it still had liquid blood, once thawed, that had been frozen blood. So
wow.
They're going to be able to get an entire DNA out of this probably.
Right.
And so we have woolly rhinoceroses. We live in a reality where I wouldn't be surprised if it's only slightly more difficult to bring back woolly rhinoceroses versus some of the recently extinct rhinoceri.
I want woolly rhinoceroses. That's cool.
And the fact that the reason we don't have mastodons and woolly mammoths anymore is human beings are assholes. Sorry, this stream
maybe. There's controversy. Maybe we hunted the megafauna. Maybe we didn't.
You know.
Maybe the sun is going to gobble up the earth when the sun dies. Maybe it won't. More evidence is necessary.
But
I mean, I'm not questioning the we're assholes part. No question. We're assholes. We might just not have killed the megafauna.
Yeah.
The tasty megafauna.
Right, exactly. So yeah, there's so many critters that went extinct in recent centuries, millennia. I mean, clearly we need to do things like the efforts to preserve that one snail in Hawaii where they like meticulously over this few acre area have gone through and removed all of the invasive species so that they can start to reintroduce the snail.
Right.
There's wild stuff going on out there.
Yeah.
But yeah, it's
So I hate to do this, but
you
I've
have
got to
go.
run.
I'm
Yeah, I got to
rambling
do an
about
interview
extinct
in.
animals.
No, it's fine. It's fine. Invasive species. My number one enemy is invasive plants and species. So now I left the end of the episode kind of ambiguous. Are we recording next week, or are we starting our Christmas New Year's break?
I don't know. Let me. I think we are. I lost my mouse again. There it is. Let me open up Trello. Because I have it on my to-do list in Trello, which means it doesn't have to be in my brain. I am that person. I scrolled into 23. Let's stay in 24. So we recorded this one. And yes, we're recording on 12/16.
12/16, right, of course, because we're on Friday. Yeah, okay, so we'll do on the 16th.
Yeah,
okay.
So recording on the 16th, and that's looking ahead to things that we want to see in 2025.
And then the 20...
That's the last of the year.
Right, okay. And then we'll be back in January. Okay, sounds good.
And I'm going to be at Podfest the 14th, which is a Tuesday, so I'll be here to record. But Monday of Martin Luther King Day, I'll be recording from a hotel. But the reason I'm mentioning this is if any of you are going to Podfest or you are planning to go to the launch of Blue Ghost, I'm going to stay an extra week and gamble on Blue Ghost getting launched because I haven't seen a Falcon launch and I have a timeshare. So I'm going to do the...
You have a timeshare in Florida?
So I was like, I travel so much, and Hilton Grand Vacations timeshare lets you use facilities all over the planet. And so I have ended up using my timeshare for everything from weddings to vacations to mostly going to try and watch launches.
Right.
So it's super convenient. That's
awesome.
So this is my goal, is to abuse the timeshare in the name of rocketry.
That sounds great. All right. Thanks, everybody. And we'll see you all on Monday.
And I found my mouse. And as always, awkward transition. Bye-bye.